says Ladyada.
Hey everybody, and welcome to my desk. It's me, Lady Ada, here late at night, hacking away. Never give up, never give in. And we have any updates or news?
We do.
Okay.
I'm gonna play the intro to one of these like new video series things we're doing, and I'm gonna talk about it. So
Okay.
here's what you'll see 10 p.m. occasionally on our social media channels.
It's 10 p.m. Do you know where your engineers are?
Okay, so we debuted our first one, and it was what were you doing Friday night at 10 p.m. And the idea of this is there's a lot of people in like the electronic community that are
Up
they're
late?
behaving like total jerks to one another, and they're really trying to make it so no one wants to do anything. It's like, what programming language you did the right run the wrong one. Oh, you chose this thing, so you're wrong, you're doing it wrong. And I wanted to kind of restart.
Hack.
Yeah, I want not a hack. I wanted to restart how people talk to one another. So 10 p.m. on a Friday night is fucking rad for electronics and engineering now. It is so much fun. There's never been a better time to do stuff. It is amazing. And just because some people have like their own issues, doesn't mean that we all need to. So at 10
Yeah.
p.m. on a Friday night, people are like, I'm 3D printing. I'm doing all this fun stuff. This is really cool. But then someone will snark them. So we're going to stop that, and we're
Yeah.
going to, well, we try to counter that
Celebrate.
and say, great, what are you doing at 10 p.m.? So what were you trying to do Friday night at 10
But
p.m.?
I'm glad I actually have it on my desk. So we've got these.
Oh, let's just jump right into the show.
Let's just jump right in because we'll cover. I mean, like I didn't get any farther
Yeah,
with it. Um.
yeah. And then let me just do a little bit of a rant here
Oh
because I'm behind because
boy.
now I'm just a microphone. I'm just like a voice.
What's funny is Baby Ada, whenever Mr. Lady Ada goes on a rant, she goes, da da
Yeah,
da da
she's sleeping
da
right
da.
now.
She's sleeping right now, but
But let me tell
when
you,
he goes off, she like joins
let
in.
me tell you,
Okay.
when you try to say, hey, like let's be good to each other. If you're a high profile maker, you could set a good example. I was told, oh, Phil, you're just being dismissive because, people should be able to be angry and vent and everything. I'm just like, you know what? Dismissive is ignoring it and saying, hey, let's just make everything terrible. Let's just not do anything. We're doing the work, and we're saying 10 p.m. you can this is when engineers do a lot of fun stuff. This isn't like, oh, you're working and, oh, what's your boss telling? No. It's 10 p.m.
We're
Do you
not doing
know
TPS
it's
reports.
10 p.m. Do you know where your engineers are?
No.
Whatever your engineers are doing for fun at 10 p.m. on a Friday night, on a Saturday night, that is what's going to be mainstream electronic engineering for everyone later. I remember, I think, like Tim O'Reilly a long time ago said, whatever makers are doing on weekends is what everything is. It's like before Wi-Fi was like everyone and
I
everything.
remember when people were
They were
making
stringing up antennas.
they were making it quadcopters. Like there was like a
Yeah.
very hardcore DIY quadcopter community, but this is before
And now
DJI,
and now it's now
before
it's everywhere and everything.
robotics. Yeah.
And so, you know, all y'all who are being jerks and everything, I'm sorry you can't find something to bring you joy, but we're doing good over here. And everyone else is doing pretty good. And we're gonna keep just celebrating the fun things to do. So you were trying to get Linux on a microcontroller. Tell me all about it.
Well, yes. So there is this project to compile ESP32 S3 Linux. So it's a very lightweight version, but I think it's a mono. It's like Linux 6.6.3 kernel. Get it compiled onto the ESP32 S3. And I happened to have, it's green, so it just, of course, it shows up on the green screen, a Metro ESP32 S3 which has 16 megabytes of flash and 8 megabytes of PSRAM, which for a microcontroller is a huge amount. For Linux is not a huge amount, but there's OpenWRT installs that can run on 8.8, 16.8. Like it's small, but obviously you wouldn't run a graphics interface, but you could maybe have Wi-Fi working on it. You could have VisiBox running on it. So I can go to the computer and just show off XP32 S3 Linux. So this is it's a little confusing because it's like there's um this person Rudy who's talking about it who made compiled builds. The person who did the work is I can't remember their entire username. It is like sorry, it's J something something something, but there's so many links here. let's see. Where's the gist? Hold on. I have the gist. Yeah, it's JCMVBKBC. That's why I can remember it. But they're the one who did a build for do the cross compile to the Extensa compiler, and also I guess I don't know the details, but usually an operating system requires a memory management unit. Like you have memory that is ring 0 and like root, and there's memory that's available to user space. And I guess they must simulate it. I don't know exactly how they handle that. But here's a script that if you run it will install the cross compiler, install their fork of Linux with all the patches and get it running. I will say that I tried the firmware binaries and I got those working. So hold on, let me re-enable this, restart session, and then let me plug this in, which will. So I'm connected to the UART pins on my ESP32S3. So you see, it is like it's running Linux. It is BusyBox, so it's like minimal, and then this particular compiled version is for 8 megabytes flash, 8 megabytes octal PS RAM. So I would have to rebuild it again, if I wanted to use all 16 megabytes of flash. And you can run MicroPython. So MicroPython, by the way, there is a Linux port. Like you can run, MicroPython can be compiled and run on Linux directly as like a very low memory Python install. I don't know if there's interface to hardware. I didn't actually get very far with this. Module. Trying to remember, or is it like? I thought there was a help. No. Dir. So it was import pin. No. Shoot. I know that you could like import UOS, and then you could like list directories and stuff. So maybe UOS list dir. Yeah, I don't know. It doesn't seem to really work. And up arrow doesn't work. So it's kind of minimal, I'll say. Like I think it just like you can, run it, but I mean you can run it and you can do like 1+1, you can do like, print low. Yeah, that works, but I guess like none of the modules or interface to the modules work yet. Control C. It is running BusyBox, so sorry, not dir. It's got a file system, but the file system is read only and it's CramFS. And I don't know if you can like mount it read write. I guess you normally do everything you need to do in /temp. And this particular one does not have network. Yeah, there's no such thing as Ethernet. So not Ethernet, Wi-Fi 0. So their latest version of the script, if you build it, will give you a Wi-Fi interface. And I was like, okay, well, I can like try building it. And like, given that I'm kind of like not great at doing cross compile stuff anymore. Like I used to really be good at like doing cross compile stuff because I would just sit there and spend forever on it. And I kind of like every time I try to cross compile this, basically if you have like your native computer is like Debian, I think you're good to go. But any other configuration doesn't work. So I tried like, okay, what if I tried WSL? But then I got freaked out because like my path on this computer, like it's like, WSL has your entire Windows DOS path. So it's like program files, open paren space. So, I was like, okay, well, I could clean up the path, and then something else will probably go wrong. So I was like, okay, let me try on my Mac. But then on my Mac, the Brewcask for ncurses doesn't include like the menu library linking. And I was like, oh my God, this is like going to be a nightmare to fix. So I skipped that. And then I tried VirtualBox and I actually got kind of far on VirtualBox, but I only had a 20 gig drive that I created for my virtual Debian install. Turns out 20 gigs isn't enough because this is installs like GCC. I mean, it's like a huge build. You probably need 100 gigs of space, which is like, just ironic because Linux people are always like, wow, your operating system is so bloated. Okay, but like compiling the operating system is also kind of bloated. Also, I think like there's a lot of Git clones that are not shallow. I think they actually like clone the entire history of like GCC and Linux. But and then the last thing I did was I tried it under MSys, and I got fairly far with that actually, and then it failed because the cross compiler was confused about what the home architecture was. So you basically like each path, each way to cross compile. I can get through it, but I was like, oh my god, I need like 3 or 4 hours to like stick around, and I just was. And the baby woke up, and I was like, I gotta get back to baby. So no success yet, but I think honestly my best bet is probably just doing VirtualBox and just having like a massive VirtualBox hard disk on my desktop, and then I just throw it away when I'm done. Or I can ask one of my devs that works for me to compile it for me. This is one of the great things about having devs that work for you. I'll be like, do you have Linux set up? Okay, can you run this config script and pop out a binary? But I thought it'd be neat because I've got this, this Metro hardware that I want to release. Okay, so that's that. So that was what we did for that video, which is all cool. So you can check it out. It's just just search for ESP32 S3 Linux, and there's a thread on ESP32.org. Okay, so next up, I think last week we talked about. Oh, can you go to overhead? We talked about maybe 2 weeks ago. We did the ICN 6211 screens. So the development boards for I ordered PCBs for let me unpause this. I'm not sure it's freaking out. For getting these high resolution 4-inch screens working. So this is a capacitive touch. 800 by 480 TFT with an RGB interface and also a cap touch overlay as well, so separately connected. And I think I got it working with DPI, but now I want to work with DSI. So and then I had some square screens. So I ordered the PCBs and they're still getting made. It takes a while to get PCBs, but hopefully in a week or two they'll show up. And then I can get this. Originally it was a DPI hat, but it'll now be a DSI hat for Raspberry Pi going, which will let me finally put this poor wiring monstrosity out of its misery, because I'll be like, okay, I got, I have a PCB that works. I can toss this out. It's kind of like totally bonkers. Don't even know why. I mean, I should probably just take it apart now, but you never know. So I'm gonna keep it there. Okay, so but while I was doing that, I was actually like, oh, I actually found out like I have like 200 of these on site, which I didn't realize. Like I had ordered these. Again, this is like a 2020 project. So I actually have the displays already on hand. And as I was searching, I realized, because I originally thought this was a 3.5 inch. This is actually a 3.97 inch, 4-inch display. But I like was searching through like the product inventory management we have, and it was like, oh, by the way, like, do you mean the 3.5-inch capacitive touch display? Because it was like trying to help me find the part I was looking for. Like, by the way, we have like literally 15,000 different parts that we manage in our product lifestyle product lifestyle management. Click them on lifestyle. So it turns out we have 800 of these displays, and I was like, that's odd. Like normally I don't have like thousands of dollars worth of parts that I don't use. So I went through my email. It turns out like I got these in like 2014 or 15. And these are 480 by 320, 3.5-inch displays. You can actually see the date code, 2014. Yeah, so I got these in 2015. And they're 480 by 320 using the HX5387D or whatever. We have the resistive touch version. And the reason these never got made into the shop is the prototype I got worked great, but actually all the displays I got had a really weird capacitive touch effect. Like something was not working with the capacitive touch. And I went back and forth with the factory that made them for me, and like it was never like they're like, we don't see this issue, and like it was never like resolved. And then I think something happened, and like they were put, I put them away onto this like shelf, and then I completely forgot about it. And the only reason that um we found them is like, first I was, trying to figure out what's up with this display from 2020, and then we were clearing out an area in Adafruit, and I found them. I was like, where were they? Okay, I found the shelf. So I'm going to try. I'm going to remake the PCB for this display. So this display is, it does have RGB pins, but I'm only going to use it as an SPI display. And then the capacitive touch comes actually here. I had this custom made so that the capacitive touch comes through on the 50 pin connector, because the 4 pins that normally would be used for the resistive touch, I had it be um, I2C clock data and then IRQ and reset. So I don't know, maybe like, I don't know, like a lot can happen in 10 years. So I'm assuming that I can, or 8 years, I can probably get it up and running. It would be a great thing for me to wrap it up. And I figure at worst, if I can't get the capacitive touch working and the company, I mean, now it's been 8 years, you're not going to fix whatever issue it is. I don't think, unless they happen to have the calibration, because these capacitive touch chips do get calibrated at the factory for you, and I don't know if they're miscalibrated. They might give you the calibration software. We could recalibrate them. If not, I could always sell them and just be like, hey, the capacitive touch doesn't work. So it has this cool black cover, but it's just a glass cover. Don't try to use the capacitive touch. So this is the board that I'm going to, oh, can you go to the computer? So this is the board, and I actually had this TFT breakout board, but I updated it. I now use TSOP versions of these 8-bit level shifters, because this is a 3.3 volt logic display, and you might want to drive it from something that has 5-volt logic. Although these days, honestly, not a lot of stuff uses 5-volt logic anymore. And then, of course, the backlight driver, updating it to use the, I think it's the TPS 61169. So I guess I do have TPS reports. I have a TPS report about this TPS backlight driver. It's a good backlight driver. And then I put an iSpy connector. So that would actually help me do the testing, because what I'll do is I'll get a bunch of these prototype PCBs and I'll quickly like connect them to different chips using the iSpy connector, so I won't have to do as much wiring. On the off chance that the wiring is what was causing this to be flaky, I wasn't imagining it. It really was. Like, I remember the I2C, the capacitive touch was acting funky, but like, I don't know. I know more about getting I2C stuff working now, maybe. So I don't know. Maybe I'll be able to get it working. I mean, either way, I would love to get rid of like 800 displays. I mean, these are easily like $6 to $10 a piece. So it's like, $8,000, $10,000 worth of displays. I know for a lot of businesses, they're probably like, how could you possibly have that much of inventory that you didn't even know about? And it's like, we have, like I said, like almost 15,000 different components. It's very easy. If I forget about it, there's nobody else who's paying attention. So I redid this PCB this weekend as well, and I ordered prototypes, so that's great. And then lastly, and this will lead into the great search, is I'm still working on, here and there, I'm working on the redesign of our 2.8-inch shield, resistive touch shield. So like a bunch of parts got discontinued, particularly the touchscreen controller. I found a new touchscreen controller that I was like going to use, the TSC 2007, which you see here, and I made a little breakout for it, and it's been good. And so I made a shield. So maybe go to the overhead and I'll show off this shield. So put these displays away. So this shield has the 2.8-inch resistive touch, and nice 3M tape there. By default, it uses the 2x3 ICSP header. it has the Arduino pinout, it has a right angle reset button, which is a nice upgrade, adds STEMMA QT because that's a new thing since then. And then uses the TSC 2007. You know, I could have gone with an SPI uh, driver, but I actually kind of decided like I would rather have that chip select pin free and use I2C because at the time, like when I first designed this board, the original version of the Shield, I2C like that wasn't it wasn't that it isn't popular, but it wasn't guaranteed that people were using it. Now, pretty much if you have I2C pins, you're going to connect I2C stuff to it. You're not going to use it for analog inputs or digital IO. Like you pretty much always have something that you would connect over I2C. And so even though the number of pins being used is higher because you're using two I2C pins instead of one chip select pin, I still think it's more beneficial because you're going to use those I2C pins for something. You might as well throw this on here. And this is, you know, it's an inexpensive chip. We covered it on the Great Search a while ago. It's like 60 cents. Very reasonably priced, and it comes in a nice package. But I was having a weird issue with it, which of course now I can't reproduce, right? Like if something is not working. But I was having this weird issue where it would latch up. And um, the latch up was really hard to, oh, you know what? It just happened. Okay. So I had this issue where it was latching up because what is happening here, let's go to the computer. Yeah, it says I can't start the touchscreen controller. And it wasn't happening all the time. Like it was happening, like I kind of always like I do things you're not supposed to do, like I hot plug stuff and I'm like kind of messing around and you know, plugging and unplugging. And I was like, this would come up once in a while. And I was like, that's really weird. Like, why would it not work? And then I would run my I2C scanner because I was like, oh, you know, I actually at first what happened is I had the address pins floating. And I thought, oh, you know, the address pins are floating. I bet the address is changing because I didn't put pull down resistors or pull up resistors on it. But then I shorted the address pins and it was still happening like it happened now. And so I was like, well, let me scan the I2C bus to see what's up. And well, now it's scanning. But what would happen before when it was not working is it would hang. It would never complete the I2C scan. The bus would actually be locked up. And when this happens, you're like, ooh, like something's like bad, something really bad occurred. I actually had the scan also in my sketch. I was trying to like figure out like what this came from, and I kind of Googled around a bit and found this app note that was like, you know, and you kind of like sometimes you read app notes and you can kind of tell they're like, yeah, we done fucked up. So they done fucked up a little bit on this TSC 2007 design. Other chips that have definitely I've read app notes and been like, wow, like you did not have the A team on it. The MCP 9600 and 9601. They revised it to the 9601 and it was still bad. You know, I don't understand exactly how that was possible, but I have a feeling that maybe there was like the microcontroller, it's firmware driven. They didn't have a good I2C peripheral for licensing. I don't know. Anyways, so what happens is that they're like, oh yeah, by the way, like you kind of have to be really careful about power up. And if you're not careful about power up, you're gonna get a lockup. And there's a lot of things that can mess up the power on reset. Now, it's not their fault. Like I understand why some of these decisions were made, but it turns out they actually I'll see the end. They came up with another chip, which unfortunately I don't want to use, that solves this issue. But I solved it in a different way, which I'll get to. So the power up sequence, it has to power has to be turned off, and then it has to be off for a significant amount of time so that this internal capacitor, which is used for like power detection, completely decharges. And then when you turn on your power, you have to turn it on pretty high, like pretty fast. You can't have like a wiggly power. It has to turn on and it has to stay on. And if it doesn't, and it has to be, you know, the off time is kind of significant, 300 milliseconds, 1.2 seconds for cold weather. I actually found somebody even who posted was like, hey, you know, like I have a device with a touchscreen controller, and when you're in cold weather, it doesn't work anymore. Why is that? so they go into the issues of what happens, but not only do you have to have the power supply be good, but there's a couple other little issues. Like for example, the on most GPIOs, especially something like a touch controller, which is like all humans putting their grubby fingers on it, you want to have good ESD protection on it because it's usually exposed, not exposed, but it's close to where high voltage ESD can come in. So the pen IRQ pin, the interrupt pin, has has protection diodes in it. But if you happen to be setting the pen IRQ pin to an input pull-up before the chip has finished its power on reset, I think that can also mess it up. And that's actually, I don't know that that was particularly what was causing it, but I had done that. So this I had set up as a pull-up, and that voltage was coming in and messing it up. And actually, you don't have to set this to input pull up. I do by default. I always set IRQs to pull up because I'm like, oh yeah, you want to be a pull up. It actually is a push pull output, so you don't have to do a pull up. Apparently, earlier versions also could be fed through the ESD protection diodes on the I2C lines, which sucks because they always have pull ups. And that's quite hard. But apparently, Rev C, the silicon, they removed this diode to remove the issue. So they're like, okay, how do you fix it? And it's like the fixes are just kind of like, they're so sad because they're like, yeah, you're gonna just like wire up a new low dropout regulator, right? And then you're just gonna like use that as a reset because we didn't put a reset pin on this on this sensor. Bummer. Yeah, because they're like, hey, the IRQ lines, SCL and SDA pins should come high after the main power. Which you can't always guarantee this depending on where your capacitance is. So what they really do recommend is I think it was like the TSC 2107 2017. Yeah. So they replaced it with this, and they're like, it's one more. Solve the problem. Problem is it's only available in BGA, and you all know how I feel about that. So, oh, annoying. Oh, it looks like there's maybe the TSC 2004. I gotta check this out. But the other thing I was thinking of doing, like, ooh, that's kind of nice. It's battery management and temperature sensor. So yeah, I mean, I designed this, so I was like, well, and it's inexpensive. So one solution, which it turned out coincidentally I could do, is I already had a reset supervisor here. I use the APX 803 2.7. And what that does is until the power supply voltage hits 2.7, it keeps this reset line low, and then it waits till you get above 2.7, and then it waits 100, 200 milliseconds, and then it pulls the reset line high. And you need that because the TFT display, a lot of TFT displays really want a reset pulse. They literally want you to pulse the reset low to get the chip into a good state. They also have a little bit of a power on, they don't have a power on reset circuit. They need a manual reset. And I often don't want to waste a microcontroller pin when it's like, I only need, you only need to pulse it once on boot. And so what I do is I use a supervisor, and that does that pulse for me to make sure that power stabilized, and then it resets the TFT. And so since I already have this on the shield, I'm connecting the output of it, which is pulled up to 3.3, into another LDO, because this uses so little power that it's not a big deal. I would, 3.3 in, this is going to be like 3.25 out. The drop is going to be very little. But I have this, this will auto reset the output power. Similarly, it'll wait till the power regulates and then gives it a good like 200, 300. I'll make sure that it's within the same spec as the app note recommends. And then I was gonna, try that and see if that works, because this LDO is only 4 cents. So I'm also gonna look at those other options, the 2004 and 2003 chip, and I might look at some other options because it's a bummer. Like some I2C sweet chips, by the way, like they're great, and then there's some that are just a real pain in the ass. I don't know how else to say it, but when they're good, they're good. when they're not good. They can take down the whole bus and it sucks. Okay, so that's the Desk Ladyada. So let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada brings you, yes, you, the best ways to find what you're looking for, part substitutions, and more on digikey.com. Thank you, DigiKey. Ladyada, what is the Great Search of the week this week?
Okay, so let's go to the overhead and I'm going to show off some shield designs. So this week I've been working on this TFT shield, and shields are devices that plug into microcontrollers like this Arduino, and I also have this Metro Arduino shaped things, and they have this version. And most shields have pin headers. So like this NFC shield has pin headers that are soldered in, and then plug in nicely. Plug in nicely over here into the socket headers. So let me see another shield. So this is like a tester shield, for example, and this plugs in nicely, nice and securely. And then you've got the pins on the top and the pins on the bottom, and they make a good mechanical electrical connection. However, there's once in a while you'll have a shield where you can't have through headers. Like for example, this TFT shield I'm working on, the TFT shield is has this 2.8-inch display, and the display is like exactly the same size as the shield. And so if I did have the pins come through, like on these others, they would come up and they would short against this metal piece that holds the backlight, and that would be very sad. Yes, you could maybe put padding or something, but especially with something that's a touch screen where people are like poking and prodding it and pushing it, there's a high percentage that even if you had a foam protector or something, that these sharp little pin ends would poke through the top and again short to the metal plate, so no good. So in such cases, I like to use surface mount headers, and you can see here these headers, the way they're manufactured is much like pin headers, except that the ends are bent over, and they're bent over alternating style, like one to the left, one to the right. And it's not as strong as through hole, but it's fairly strong. Like I've had fewer issues than I'd expect, especially if you're using long number of pins. Like I went 2 pins, I don't know, that would be really tough. There's not a lot of mechanical strength. But once you get to 6 or 8 or 10, there's enough alternating solder pads that are really held down that this is, pretty much as strong. Like, I mean, if you really wrenched it, it'll break off. But if you really wrench these, they'll break off too. So, or they'll bend. So, this, and then of course this 2x3 socket header make for a very elegant connection when you don't want any pins sticking out the top. There's a lot of different reasons. Maybe you also want to have a very clean design on the top. They do cost a little bit more, but they are stocked at DigiKey. I thought I'd show people how to find them, since we've done pin headers before, but we've not done surface mount pin headers. So let's go to the computer and let's search for header. That's what it's called. And there's the specialty header, and you'd think that maybe it would be under specialty header, but actually specialty header is like really the weirdest stuff you've ever seen. Like these really like crimping ones, and these ones where you can solder into the cups. They have like solder cup ends, very in like Swiss pin style. These are definitely the weird ones. Cool things here, but not what we're looking for, because we want the surface mount. So I mean, look at this. Like, what is going on here? Milmax. I mean, there's 3,000 in stock. This must be useful for something. Slots. I don't know what that's for. Check out the data sheet. Okay, so but what we want is just pin headers. And there's of course also socket versions of these as well. Oh, let me go over, I'll show quickly on the overhead. I'm not gonna cover it on the Great Search, but if you just mimic exactly what I'm searching, but in the female socket header area, and you can see this Metro also doesn't have headers that go all the way through. They also are socketed and have alternating legs. And, there's a couple different reasons to do this. One, you want a really nice smooth bottom here that can't short against anything on the table. But also for manufacturability, you can pick and place these components. And in this particular case, this one was made before we had a selective solder machine. And so it was actually easier and cheaper for us to pick and place these surface mount headers than it was to hand solder all the pins. Now, we have selective solder, and we have partners that do wave soldering, so we can, or hand solder, so we can do that for these through headers. But there's quite a few pins, so they do add up. Okay, sorry. Let's go back to the computer and continue on our quest. So we want stacked. We want active. And I'm going to look for, only one row. Oh, they do have surface mount dual row, but not triple row. Dual row, the pins go like, they go out like this, but 3 pins, there's nowhere for that third pin to go. So for 3 row, like if for servo connections, you would, if it's 3x4, you have to go through hole. I'm going to go looking for only 1 row for now, but again, you want 2 row, just like 2 row. Pin pitch. In this case, we're looking for your classic 0.1 inch, 2.54. And then number of pins, again, pick however many. In this case, I'm doing 8 because that's common. But on an Arduino shield, Arduino compatible shield, you'll want 6, 2 8s, and then 1 10. Oh, and they're unshrouded. There's no plastic around them. Okay, so apply. It looks like from a 500,000 down to 175. You can take a look. Okay, so we have, there's definitely, whoa, these are like kind of weird pins. Let's go availability. Did I pick something wrong? Because these are unusual. Weird. I don't think so. Why did I pick number of rows, 1 row, 8 pin, pin pitch, 0.1, product status, active, shrouded, unshrouded. I don't know. Let's also look for only. Oh, I must have done something. Let me clear these out. I don't know what happened here. Actually, I'm just gonna go back to the category. Whoa, something really bad happened here. Let's go back. I'm gonna start over. Maybe I selected something wrong. Okay. Pins. Okay, so I want active. And I'll do number of rows 1 or dash. And let me pick normally stocking. Let's see. I like to look. Okay, yeah. So I'm getting reasonable looking stuff. And then I want 8 positions, 8 pins. Okay, apply. This is a little slower. I'm just going one at a time and making sure that, yeah, okay, I'm seeing stuff that looks reasonable. And then I don't want no shrouding. Let's see. Okay, yeah, so I'm getting all the through-hole versions. So if you want through-hole pins or right angle, these are what's showing up now. Okay, cool. But now I want pitch of 0.1. And I'm also going to select the dash here in case that has stuff. So let's select that. And yeah, most of them are still going to be here. Looks good. And then surface mount. So there's also right angle surface mount, which I'll show. Honestly, right angle surface mount header is, I think, is tougher to mechanically support, because at least with the vertical, the style that points up, you have like those alternating legs that are bent out. With the right angle style, they look like this. There's really, like, it's so easy to rip those right off because there's nothing keeping them down onto the PCB. So, and here's some of the ones that we are looking for. So, yes, they do exist, but you really need to have something mechanical on top, holding them in place so they don't get torn off. Even the more pads doesn't help. Like maybe if they were like really huge pads with lots of vias, maybe like it would be mechanically strong, but I don't think so. Okay, and then I wanted to come on. We'll talk about the oppositions loaded. Let's do that. And then I'm gonna get rid of the right angle because I actually don't want right angle. I want the straight up style. Okay, cool. Lots of options here. Let's also pick ones that are in stock. And it's something interesting. So some of these come in a bulk package. So bulk means they're like literally in a bag. And these are a little less expensive. So if you look at these two, these are like the same part, but one of them comes in bulk and one comes in tape and reel. And you'll notice that the bulk one is a tiny bit cheaper. When you get these on tape and reel, they're going to come with a little tape cap, a little piece of plastic that allows the pick and place to pick it up. And also the reel is like kind of tall and chunky. So the reeling itself, it's like not inexpensive. So it's a little bit more pricey, but I'm going to use it in the pick and place. So, and if you're using it with a contract manufacturer, they're definitely going to be like, hey, you need to give it to us in tape and reel. I wouldn't take it in bulk or a tube. Those are going to get stuck in the tube, or they're going to be hard to hand place. But if you happen to be hand soldering these or hand placing them, bulk is fine, I guess. And then contact length. I think these are 5. Let me just quickly check my multimeter. I mean, you can of course get shorter headers, but let's see. Grab these, and the contact length I want is it's about 6 millimeters. Yeah, so these two, and then this is like long, and then this is like short, little shorty style. And then you can choose gold or tin. Honestly, I feel like these days gold finish is kind of where it's at. Okay, so we're down to 5 options. Let's look. Some things from Samtech, and some this option from 3M. Samtech, a couple different options. Definitely the least expensive is going to be this Econo stick, at about 20 cents in quantity. This is my pick. I'll say one last note on these. So this, yes, you can see this is the picking cap, the pickup cap. So it's stuck on and you remove it when you're done. One thing I will note is that, and this has bitten me, is that this layout, whether it's the rightmost, this rightmost pin or leftmost pin is up or down, is not consistent between SMT headers. And I've run out of like an SMT header and been like, oh no, like let me find an alternative, and realize that it was the alternate orientation, like the pins were the opposite way. And so honestly, I recommend if you're going to do the layout for these and you don't have a guaranteed, I have this connector and I'm 100% sure I'm always going to have this connector, even though this has alternating like zigzag contacts, you should put in the missing ghost contact here and here and here, like where these crosses come. Have another set of contacts, and the paste will just go on them and they won't be used. But if you happen to need to swap the orientation because you can't get one and the other, like the replacement you have happens to have the other way around, you can pick and place it and it'll still work fine, because you'll have both contacts. So believe me, it's happened to me. And I was like really bummed that I was just like, oh my God, I have like 5,000 of these connectors and like I can't use them, or I can use them on the next revision. So the next revision I did the alternate. And now I have I've standardized and I have the connector, and I'm careful with that. But just as an alert that there's chiralities to these SMT headers. So this is my pick for a great search, and it's in stock even.
That's a great search.
Where in the world is that part I need? The Great Search with DigiKey.
And that's our show for tonight.
All right, thanks everybody. That was a little long, but
There's a journey. It's fine.
let's stop going to my desk.
It's not a long time when we don't want to do anything else. That's what we like doing.
I know,
So
it's 10 p.m.
Yeah, do you know where your address is? Okay, we'll see everybody during the week. Thanks so much. We got a full lineup of shows and more. And I found that if you're around, even online, interesting, ambitious people who share and have fun and high five each other and like go into the skate park virtually in our heads and hitting that new trick and pushing the state of the art, you'll be a lot happier.
Yes.
So we'll see you around. See you at the skate park. Bye.
Cool kids.